In section 4, we're going to talk about ellipses. So an ellipse is very similar to a circle, except it's just elongated in one direction. So it's kind of like an egg. So the definition of an ellipse is the set of points whose sum distance from two given points, called the foci, is a constant. So that means is if you're looking at our picture of an ellipse here and I pick a point on the circle, my foci are specific points. So they are something you can figure out from the equation. But you have your two foci and you have your point on the circle. There is a distance between that foci and that point, so those two distances, D1 and D2. And what it tells me is when I add those two distances together, I get some constant that we'll call K. And it works the same way with every point on the circle. So if I have a separate point and it has a distance, let's call it L1, and a distance L2, the sum of those two distances also equals that same constant K. So when we talk about the equation of an ellipse, wherever the wider is the major axis. So if it is wider along the x-axis, we say that its major axis is the x-axis. So that's where you get something that's wider along the x-axis. So the equation is x squared over a squared plus y squared over b squared equals 1. So an ellipse equation is always equal to the number 1. So a is the distance from our center to our vertex. B is the distance from our center to our co-vertices. A will always be bigger than B, and they obviously both have to be greater than 0. And we also have a formula called b squared equals a squared minus c squared. And this is to help us find our foci, because c is going to be the letter that represents our foci. So for an example, we want to find the equation of ellipse with a focus at -7, 0 and one vertex at 10, 0. So we have that C is 7 because C is the distance from our center to our foci. And then our vertex is going to always be A, and that is 10. Because we're centered at the origin, that means our vertex is at 0, 0. So you're just going to that distance. So now I need to find B. So B squared equals 10 squared minus 7 squared. That's going to be 100 minus 49, which means B squared is 51. I don't actually have to find B because I'm writing the equation, and the equation is in terms of B squared. So my equation is going to be x squared over 100, since 10 squared is 100, plus y squared over 51 equals 1. Now, in our next example, we are going to graph our ellipse. And we want to make sure we label all of our vertices and then our foci. So we're going to start with finding A and B. So A is the square root of the larger number, so the square root of 25, which is 5. B is going to be the square root of 8, which is not a perfect square, so it's not going to be a nice number. It is going to be a decimal, which is okay, and it's going to be 2.2. And now we have C. Now we need to find C, so we need to find our foci. So we have that B squared, which we know is 8, equals A squared, which is 25, minus C squared. So we're going to subtract 25 from both sides, and we're going to get negative 17 equals negative c squared. Divide by negative 1, and we'll get c squared equals 17. Take the square root, and c is going to equal 4.2. So now I can go ahead and graph my ellipse. So I start with my center at 0, 0. A is 5, so I'm going to go 5 to the right and 5 to the left. B is 2.2, so I'm going to go slightly up a little past 2 and negative 2. And then for my foci, I'm going to go a little bit past 4 and negative 4. So we've got vertice, vertice, co-vertice, co-vertice, and then my foci. So when I connect my vertices and my co-vertices, I end up with my ellipse. We also can have an ellipse centered at the origin whose major axis is along the y-axis. So that means it's longer going along the y-axis. And the only thing that changes in our equation is the location of a squared. So it's now x squared over b squared plus y squared over a squared equals 1. Everything else has stayed the same from the definition when the major axis was the x-axis. So now we're going to do an example where we graph x squared over 9 plus y squared over 100 equals 1. So in this case, a is going to be the square root of 100, which is 10. B is the square root of 9, which is 3. And in order to find c, we'll do b squared, which is 9, equals a squared, which is 100, minus c squared. Subtract 100, we get negative 91 equals negative c squared. Divide by negative 1, c squared equals negative 91. Take the square root, and we're going to get that c is about 9.5. So when I go to graph this, you got your center at 0, 0, my vertices at 10 and negative 10, along the y-axis. My co-vertices are going to be at 3 and negative 3 on the x-axis. And my foci are going to be on the same axis as my major axis, so at positive 9.5 and negative 9.5. And now we connect our points. And we have our ellipse. We are not always going to be given our ellipse in the form that it needs to be in. So in that case, we can convert it to the correct form. So if I have 20x squared plus 10y squared equals 20, and I know it's an ellipse and I want to graph it, I need to make sure it's equal to 1. So to make it equal to 1, we're actually going to divide. And I'm going to divide everything by 20, because 20 divided by 20 is 1. So I do that, 20x squared over 20 becomes x squared over 1, plus 10y squared over 20 becomes y squared over 2 equals 1. And the reason why I still wrote the x squared over 1 is that so it's easy for me to identify a and b for my equation. So a squared is always the bigger denominator, which means a squared is 2. So a is the square root of 2, which is 1.4. B is the square root of 1, which is 1. And now to solve for c, we'll do b squared, which is 1, equals a squared, which is 2, minus c squared. Subtract 2 from both sides, we get negative 1 equals negative c squared. Divide by negative 1, c squared is 1. Take the square root of both sides, and c is also 1. So when I go to graph my ellipse, our center is at 0, 0. A is 1.4, so and because it's with y, it's going to be along the y-axis. So up 1.4 and down 1.4. So the vertices. B is 1, so you go right 1 and left 1. That gives us our co-vertices. And then our foci, positive 1 and negative 1. So I connect my points. Very, very small ellipse because A and B, not very large. It's actually very, very close to being a circle because A and B are so close to each other, but it is not quite a circle, but it is close to one. So just like we can have parabolas that are not centered at the origin, we can have the same thing with ellipses. And we just shift our center to some new point HK. And that point HK is our vertex. And it works the same way with ellipses as it did with parabolas. So we want to find the equation of an ellipse with a center at -3, 1, a vertex at -3, 3, and a focus at -3, 0. So the vertex tells me if it opens along the x or the y-axis. So I'm going to graph my center and my vertex. So my center is at -3, 1, and my vertex is at -3, 3. So whichever direction the vertex is in relation to the center tells us which axis is our major axis. And because it is above, that tells me that our major axis is the y-axis. So we're going to use the equation for our major axis. So when we do our general form, it's going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. So that's the equation of an ellipse not centered at the origin, whose major axis is the y-axis. Now I need to plug in A and B. And I already know A. I just need to find B using the formula in the notes. So b squared equals a squared. So the distance from my center to my vertex, which is 2. So 2 squared minus c squared. So my focus is at -3, 0. So that distance is 1, so 1 squared. So b squared equals 4 minus 1, which means b squared equals 3. And if I'm trying to write the equation, I don't actually need to find b. I can leave it as b squared. So when I write my equation, it's going to be x, and then the opposite of the x value of your vertex, so plus 3 squared over 3, plus y, and then my y value is 1, so minus 1 squared over 4 equals 1. So in our next example, we're given the equation of an ellipse not centered at the origin. We want to identify the center, our vertices, and our co-vertices and our foci, and then we will sketch a graph. So remember, a squared is always bigger, so a squared is 25, which means a is 5. B is then going to be 4. And to solve for c, we'll use that 16 equals 25 minus c squared. Subtract 25, you get -9 equals -c squared. Divide by -1, c squared is 9. Take the square root, and c is 3. So unlike when the ellipse is centered at the origin, these are now just, either 0, 5 or 5, 0. You don't have to really worry about it. Because our center is no longer at the origin, the coordinates of my points now are a little bit different. So my center is at the point 2, -3, which means my vertices are going to add and subtract from the y value of my vertex. So -3 plus 5 is going to give us 2, 2. -3 minus 5 gives us 2, -8. For the co-vertices, you add and subtract your b value to your x coordinate. So 2 minus 4 is going to be -2, and then you use the original y coordinate, -3. And then 2 plus 4 is 6, and then my original value of -3. And then for the foci, they get added and subtracted along the major axis. So I'm going to add and subtract 3. So 2 and then -3 plus 3 is going to give us 0. And then -3 minus 3 will give us 2, -6. And you can always figure out these points after you've graphed it as well. So if you want to apply use the distance that we found for A, B, and C to find the points afterwards, that is also okay. So I'm going to go to my center, 2, -3. And then my A value, I'm going to go up 5. And that's one vertex. And I'm going to go down 5. And that's my second vertex. So again, it matches -2, 2. Sorry. Graphed this wrong. So 2, -3. So 2, 2, and 2, -8. So my center and my vertices. And then for my co-vertices, we're going to go left 4 and right 4. So we get -2, -3, and 6, -3. And then for my foci, you go up 3 and down 3. And you get 2, 0, and 2, -6. And now we just connect our points to get our vertex. Sorry, our ellipse. Last example. So we want to graph our ellipse and label all of our points for our vertices and our foci, but it's not in the correct form. So we have 4x squared plus 3y squared plus 8x minus 6y equals 5. So unlike the last example I did like this where I could just divide everything by 5, I can't actually do this here because I don't just have 4x squared and 3y squared. Like I don't just have an x and a y squared term. I have some other values, which means I have to use completing the square to convert this to the correct format. So the first thing I'm going to do is reorganize it so all of my x's are together and all of my y's are together. So we'll have 4x squared plus 8x and then plus 3y squared minus 6y and then equals 5. In order to use completing the square, the coefficient of your squared term has to be 1, which isn't the case here. So what I'm actually going to do is factor out whatever the coefficient of the squared term is for x and y and put parentheses around it. So for 4x squared plus 8x, I'm going to put a 4 in parentheses in front of the parentheses, then I'll have x squared plus 2x. And then for the y's, I'll factor out a 3, so we get y squared minus 2y. Still equal to 5. Now, what's inside the parentheses, I can do completing the square. So remember, you have to add b divided by 2 squared to make it a perfect square. So for the x's, that's 2 divided by 2 squared, which is 1 squared, which is 1. And for the y's, it's going to be -2 divided by 2 squared, which is -1 squared, which is still 1. So I'm going to have 4 parentheses x squared plus 2x plus 1 plus 3 parentheses y squared minus 2y plus 1 equals 5. Now I do need to add numbers to the right side, just like in regular completing the square, but I'm not just going to add 1 twice. Because I have that number in front of the parentheses, I have to actually multiply it. So I have to take the number I added in the parentheses, 1, multiply it by the number in front. So I'm actually going to be adding 4 and 3 to the right side. So now when I factor, it'll be 4 and then parentheses x and then whatever b divided by 2 was, which in this case is +1 squared, plus 3 parentheses, and then y, and then it's b divided by 2, which was negative 1 squared, equals, and then 5 plus 4 plus 3 is going to give us 12. Now I can go through and divide everything by 12. That is my last step, because now I just have squared terms on my left side. So 4 over 12 is going to give us x plus 1 squared over 3, plus 3 over 12 gives us y minus 1 squared over 4 equals 1. So now I have an ellipse in the correct form where I can identify its center. I can then also find A, B, and C. So my center is going to be at negative 1, 1. A is going to be 2. And B is going to be the square root of 3, which is going to be 1.7. And just to save some time here, I'm not going to go ahead and find my foci for this one. C is going to be fairly small. I'm pretty sure C is actually going to be 1 in this case. So not very difficult. You can check it on your own. So when I go to graph this, start with my center, negative 1, 1. I'm going to go up 2 for my vertices and down 2. And then I have to go right 1.7, which is almost 2, for my co-vertices, and then left. And then we have our ellipse. So if I wanted to do the coordinates for my vertices and co-vertices, my vertices have coordinates of negative 1, 3, and negative 1, negative 1. The co-vertices, not as nice because B is a decimal, so negative 1 minus 1.7 is negative 2.7 comma 1, and then negative 1 plus 1.7 is 0.7 comma 1. So please let me know if you have any questions about an ellipse, especially when it comes to ellipses where their center is not at the origin, and especially something like this last example where you have to use completing the square to get the ellipse in the correct form.